Hello students, now in this video we will be looking for the last kind of non-parametric test called as Kruskal's Walli's test. Now this one is also called as H test. So H test and Kruskal-Wallis test is one and the same. Okay. Now what the only difference between this is, see, first test which we had seen was Mann-Whitney test for two for comparing two kinds of samples. Okay. Now this Kruskal Wallis test is for comparing more than one independent random samples. So it is quite actually similar with Mann-Whitney test, but with Wilcoxon signed rank test and the earlier test which we have seen, that is a Friedman test. This Wilcoxon and Friedman, the samples were in pairs. Again, in this Kruskal Wallis test, similar to Mann-Whitney test, the samples are independent of each other. Okay, so my h naught will be always in this case that mo- the samples come from identical population. That is what, there is no significant difference between the samples. But the most important thing is that they are independent samples. Okay, they are not in pairs when this Kruskal Wallis test can be used. So the test statistic is given by H is equals to 12 upon capital capital N into N plus 1. I will explain what is this capital N, to R1 square upon N1 plus R2 square upon N2 plus, it goes on till the how many number of samples are there, minus 3 N plus 1. Okay, this is the test statistic. Then again it will be compared with the tabulated value and there will be a conclusion about accepting or rejecting the H naught. We'll see with this an example. A clinical study was conducted for three different COVID-19 vaccines and observed for complete immunization in days by a suitable method. Use KW test, or Kruskal Wallis test, at 5% level of significance to test whether the three vaccines are effective equally. Okay, so with this thing, we know that my H naught is setting up that the three vaccines, there is no significant difference between the three vaccines. Now with this, you know what will be my alternate hypothesis H1, that there is a difference between this, and the level of significance has been mentioned in the question that it is 5%. Okay, so now let's see. Okay, so in this case, the time required by vaccine X for complete immunization is, in this 5 people is listed. Okay, this is in days. This data, all data is within days. So when these 5 people were tested with this vaccine X, the first person required 30 days for complete immunization. Then the second person took 27 days for complete immunity buildup. Third person took 34 days. Fourth is 15 days. Fifth is 18 days. So it was only tested on 5 people. Now vaccine Y was tested on 1, 2, 3, 4, 5, 6, 7 different people. Okay. So first person took 34 days, next person took 35 days, next 19 days, etc. Similarly, this vaccine Z was tested on 6 different people. Okay. So now in this case, from this we know that my n1, that is the number of observations of vaccine X, is n1 is 5. N2 is 7 and N3 is 6. Okay, so now with this we know that my capital N, which we have used in the formula, is N1 plus N2 plus N3. It is the summation of all that comes out to be 18 in this case. Now the next step is allotting the ranks to this. Now allotting the ranks, the procedure of allotting the ranks to this is similar to my man Whitney test. That is, all the datas are combined together. Okay, all the 18 observations, 5 of these, 7 of these, and 6 of these, they have been taken as one. They are been taken as one sample, and the ranks are allotted to them. Okay, and now in the ascending order. So the out of all these three samples, which one is the smallest will get the lowest rank. Okay, so if we go to see, the smallest number of all this is 15 from this vaccine X and 15 from this vaccine Y. Now that means what? One will get rank 1, another will get rank 2. But there is a tie between them, that is both are 15, therefore how to allot the ranks to them? The average of the two ranks, that is 1 plus 2 divided by 2, that is 1.5. So this one will get rank 1.5, this 15 will get rank 1.5. Okay, now after 15, which one is the next smallest element? That is the 18. Okay, now first and second rank are gone, therefore 18 will get the third rank. Similarly, we have to allot the ranks to all the data. Now, if you are getting confused with this, you can combine this data, all the data, and write down as we had written for the Man-Whitney test. All data in as a one series, and then allotting the ranks and mentioning whether it is X or Y or not. Okay, but I just did this just to save the time. Okay, so it is that writing that in a series is also fine, or directly allotting the ranks is also fine. This directly allotting the ranks will be quite a shortcut procedure. So now after 18, next rank is the rank 4, and it will go to, after 18 the smallest element is 19, so it will go to 4. Then after this, the smallest element after 19 is comes out to be 20, no, 21, no, 23, 24, 25. It comes out to be 27. Okay, so 27. How many 27s are there? This one from X, one from Y, one from, and two from Z. So how many ranks it will get? 5, 6, 7, 8. So 4 ranks in total. So it will be what? 5 plus 6 plus 7 plus 8 divided by 4. That is the average of all these ranks. And that comes out to be 5 plus 6 plus 7 plus 8. That comes out to be 26. 26 by 4 is 6.5. So all these ranks, 27s will get a rank 6.5. Okay, 6.5. Now after 27, we have 30, that is from vaccine X, that will get rank 9. The next element after 30 is 34. Now 34 is twice, that is 34 in X and 34 in Y also. So now that is the ranks are 10 and 11, and the average of 10 and 11 is 10.5. So 10.5 and 10.5, these are the ranks for that. Now after 34 comes the 35, and there is only 135. That means now 10 and 11 ranks are gone, so 35 will get the 12th rank. Now after 35, it is 45, so it will get the 13th rank. After 45, it comes out to be 54. From this Z, it will get 47, sorry, 14th rank. Sorry, after 45, it is 54, which will get 14th rank. Now after 54, it is 67, which will get 15th. then it's 78 with the 16th rank, then the 79th with the 17th, and 85 with the 18th rank. Okay, so now all the ranks have been allotted. Now next thing what I will do is I will just add those ranks. Okay, add all the ranks of this vaccine X, add all the ranks of this vaccine Y, and add all the ranks of this vaccine Z. So now my R1 will be adding all the ranks of vaccine X, that is 9 plus 6.5 plus 10.5 plus 1.5 plus 3, which comes out to be 30.5. Then vaccines Y. The ranks of vaccine Y will be 10.5 plus 12 plus 4 plus 1.5 plus 6.5 plus 16 plus 13, that comes out to be 63.5. Next, vaccine Z, the R3, the sum of all the ranks will be 15 plus 14 plus 6.5 plus 6.5 plus 17 plus 18, that comes out to be 77. Okay, so R1, R2, R3 have been found. Next step is substituting it in the test statistic H. Now H is given by what? 12 upon n, n plus 1. Now this capital N we know, that is small n1 plus n2 plus n3, and that came out to be 18. Okay. So after that we have r1 square upon n1 plus r2 square upon n2 plus r3 square upon n3. Now there were only three comparisons, therefore we'll stop here, and it will be 3 n into n plus 1. Okay, now we'll substitute the values. 12 upon n capital N is 18, so it will be 18 into 18 plus 1, that is 19. Okay, then r1 square, r1 is my 30.5. Now from 30.5 the whole square, it comes to around 930.25. Okay, divided by n1. N1 is what? N1 is 5, that is the number of observations or the sample size of sample X. And R2 square, R2 is 63.5. 63.5 the whole square divided by 7, plus R3 square, R3 is 77 the whole square divided by N3, that was 6, minus 3 times n. Capital N is 18, 18 plus 1, 19. Okay. So if you solve this further, you will get the answer, this H, calculated H value to be around 4.25. Okay. Now this is your calculated value. Now we need to calculate the tabulated value. Okay. For that we know the level of significance 5%, and alpha, that is alpha value to be 0.05. Now I need a degree of freedom. Now degree of freedom for this is k minus 1. Again, k minus 1, and k, what is k minus 1? The number of samples compared. Now in this case, how many samples are compared? 3 samples are compared. So k value is 3. So 3 minus 1, that is 2. Okay. So degree of freedom is 2 for this 0.05 level. So we'll move to the chi-square distribution. So degree of freedom is 2 again with this 0.05, that is, as we have seen, 5.991. Okay. So my tabulated value from this chi-square distribution is 5.991. Now if we see, my calculated value is less than this tabulated value, that is what, 4.25 is less than 5.991. Okay, that means what, my H naught is accepted. That is what, conclusion, finally conclusion will be what, there is no significant difference between the three vaccines. Okay, so this is the end of this problem. So I'll just revise this Kruskal Wallis test, also called as H test. Now just remember this. Okay, both the names can be given, or either of the names can be given in the question, so don't get confused. So in this case, when the samples are independent, okay, at that point of time this Kruskal Wallis test is used, and this test statistic is given by this: h is equals to 12 upon capital N into n plus 1 into r1 square upon n1 plus r2 square upon n2, and so on till minus 3 n plus 1. Okay, so in this case the h naught has been set up first, that is there is no significant difference between the given samples. The alternate hypothesis has been set, then level of significance is set, and then the ranks have been allotted to all the samples which are given. Okay, so once the ranks has been allotted, the rank sum has been taken for various samples which are under test. Okay, then n1, n2 and n3, these are the sample sizes of each samples. Okay, and the capital N is given by n1 plus n2 plus n3, that is the sum of the all observations. It comes out to be 80. Okay, and after that all the values have been substituted in the test statistic, that is our h, and then the value has been calculated, and again the calculated value is compared with the tabulated value. Now tabulated value is calculated based on your level of significance and your degree of freedom, the degree of freedom which is given by k minus 1. And what is k? That is how many kinds of samples have been compared, that is give the number k. Okay, so this is how you proceed with the Kruskal Wallis test or the H test. So with this, the four tests or four kinds of non-parametric tests have been completed.